Hello guys, today we will see about dynamic polymorphism or runtime polymorphism in C++. So polymorphism is nothing but the function binding will happen during the runtime of the program rather happening during compile time. So the function binding won't happen during the compile time. It will happen during the runtime only. So this is achieved in inheritance only by using overriding. So let's see an example for this dynamic polymorphism. So I'm creating a base class and I'm creating a function. And here I am just printing base fun and I'm inheriting this base. I'm creating another class derived which is inherited from base class. So here also I am overriding this function fun, and here also I am printing some text like it is printing derived fun. So this is base class and this one is derived class. So just we will see how the function how it will behave based on the function objects we create. So I'm creating a base object B and I am creating a derived object D. So I am calling the same fun function using D object and B object, and I will try to run it. We will see what is the output. So sorry, I'm getting some compiler. See, this is straightforward. So this B, it is base object. When I call fun, it will call base function. And similarly, if I call fun of derived object, it will call derived fun object. This is straightforward. So here there is no dynamic polymorphism or runtime polymorphism happening. So the function binding will happen during the compile time itself. Then how we need to achieve dynamic polymorphism? This dynamic polymorphism is achieved only during by creating a pointer. So let's create a pointer of type base, and I'm creating an object base, and I'm creating an object of derived, and I am creating an object derived. Now I am trying to call this fun using these newly created objects. Oh, this B and D are already I have created, so I'm naming this objects. So now let's see what is output. Again, it is the same. So it's just the only difference is these two objects are created in stack. These are created dynamically created in heap. So that's the only difference. So then how we need to achieve dynamic polymorphism? So let's see another case where I am creating a pointer of type base, but I am initializing with an object of derived object. You may wonder if this is allowed because this is of type base, but I am assigning a derived object. Is this allowed? Is it permitted in C++? Yes, it is permitted because this derived is nothing but base. So if you see the relation between the derived and base class, it got inherited. So derived is a base. If you see the relationship, is a relationship. So we can this is possible. So just keep in mind. So this derived object can be assigned to base pointer. So keep this in mind. So now if I call function, which one will be called? It may be confusing because here it's of type base and here it is of type derived. So in both the classes I have fun function. Which one will be called? It's confusing, right? So let's see by running the program. Oh, I am getting some error. Sorry. This B1 is also already I have created with same name. So I'm renaming it. So base function is getting called. Why? Because this B2 is of type base. So whatever I am assigning, this compiler won't don't care about it. It will directly call the base function. So now also dynamic polymorphism is not achieved because directly it is calling based on the type. Then how we can achieve dynamic polymorphism? So this dynamic polymorphism is achieved only by introducing virtual function. Virtual function. What is virtual function? The virtual function is we can declare a function by adding a virtual keyword before the function like this. So now this function becomes virtual. So now the dynamic polymorphism is achieved. So there is no change in the main function, same code, but let's see what is the output here. Base derived, base derived, base. This is a function call happening, but by adding only single keyword virtual, let's see what is happening now. Before we had base derived, base. Before we had base here, but now we are having derived here. How is it possible? So this is dynamic polymorphism. So if we declare any function as virtual, then uh, if I create a pointer of type base and whatever the object is created and that corresponding function will be called if I call using the base pointer if that function is virtual. So this is runtime polymorphism. So all these pointers uh, we are all are pointers, but only this virtual function based on the object it is getting called. Function is getting called. So if we introduce virtual to some particular function, all those function call will the function call if it is called using pointers or references, it will be binding will happen during the runtime. So this is dynamic polymorphism. So dynamic polymorphism is nothing but function binding will happen during the runtime of the program. So it is achieved by adding making a function virtual and by overriding it in the derived class. And this dynamic polymorphism can be achieved only when we create an object which is of base class pointer or a base class reference. And whatever object we are assigning to the pointer, that object's function will be called. So if I create a same pointer b3, but if I assign base object, now base class function will be called. Let's see the output. See, base is getting called. So if I inherit some other function like derived 2 from derived, and if I create an pointer base equal to new derived 2, and if I call that pointer fun, then this variable will be of type base only, but Based on the object created, if it is derived to, the corresponding function from derived to will be called. So only if it is virtual. If it is not virtual, then directly this base function will be called. If this one is not virtual, then directly base function will be called. So this is dynamic polymorphism. So what is the use of this dynamic polymorphism? So consider we need to call this particular fun function for all the objects which are derived from base. Consider that is the situation. So we can just simply write a function like call fun, and which accepts base pointer. We can directly call fun. So we no need to care what is the object we are passing here. It will directly call the corresponding uh, object's fun function. So call fun of, now I am passing b2, and again I am passing b3, and I am trying to run this program. Inside call function, it is just accepting the base pointer only, but based on the object we created, it is directly calling derived function. Here we don't have any anything related to base, any information related to base, but by just calling the fun function, it will directly call the derived or base class function. So this is the main use of dynamic polymorphism. So we don't need to know what is the function, like what is the object we are getting passed. We can just pass a generic pointer as base. So using that pointer, we can just call the fun. But the object assigned to this base pointer, it will be properly called if we have enabled the function as virtual. So this function binding will happen during the runtime of the program. So this is dynamic polymorphism in C++. So this is simple. So then in next video we will see how this virtual uh, how this dynamic polymorphism is achieved inside compiler. In background what happens so that this dynamic function binding will happen. So let's see in the next video. Thank you.